I chose to attend because there are other talks that I think just being there in person really helps you engage and connect with people who have similar interests and even different perceptions. So it's just nice to be here in person.
Hello everybody, I hope everybody's enjoying CppCon so far. I hope that hasn't stopped now. I'm Dietmar Kühl. I'm one of the many Bloomberg people over here. The work I'm going to show is actually nothing I do at Bloomberg. This is pretty much what I'm doing in my spare time for the last half a year or something. And just to manage expectations, I will implement a very simple HTTP server. It will be very simple because there's not much time, but it will be all asynchronous, although we probably in the examples won't see the asynchronicity, but you can see the asynchronicity if you try it out. So, objective, create a basic HTTP server. It will be all single-threaded. I cannot be bothered to do threads for that. And it's even, in many cases, threads are not needed. It will be all asynchronous and minimalistic. The basic design, as one would imagine, main just runs an event loop, and which is basically used for doing networking stuff and timers. And it also uses an async scope to hold on to outstanding work. I will explain that when we go there, but the basic design is, right, we have a scope where we chuck work in, we have an event loop which we can run, and then we just get connections. Every time we get a connection, we create a new client or client handler and deal with that. I use an implementation which is basically done as part of the Beeman project. Beeman project, I will talk only very briefly about that because David is talking about that on Wednesday, I think, in way more detail. It's basically the idea we want to get implementations matching the standard specification ahead of actually standardizing it ideally. And Boost was in that space and created things like that. It didn't quite, it produced quite a number of good things, but nowadays we don't get a lot of actually proposal or implementations out of there which match the specification. The hope of the Beeman project is to basically have all library specifications have an actual implementation matching the specification. I will use two of these. One is for std execution, which is very exciting, landed in C++26. This is, in my mind, a really big, huge step. It's basically a model is an abstract interface for all kind of asynchronous stuff. Unfortunately, it doesn't come with any actual work. So actually any asynchronous operations. This is where the networking stuff comes in. This is providing kind of a binding to networking. The std execution was mostly driven by people who want to do more compute. They want to bind to graphic cards and multiple threads. I want to do it for asynchronous work in I/O. The Beeman project is named after Beeman Dawes, who is well known as chair of the C++ library working group for a while. He did found Boost, and of course he is the writer of the Dragon Duck, which informed the logo over here, this one. And I have a picture of Beeman riding his steed. Here we go. So as Beeman, he unfortunately passed away, but he basically wanted to foster the standard library and make it become better. If you want to code along, here's a QR code. You can scan that. That is basically just a link to the repo, which I just said. And with that, I will actually go mostly on to programming. So, for the programming, empty directory. I will actually start just to show this is basically the idea of the Beeman project is to have things really easily usable. I will just download an implementation, basically just clone the GitHub repo. I clone it into a separate directory, so just to keep it away from my normal implementation and hope the internet works. And all right, downloaded, excellent. Let's see how to build that thing, readme. Oh, I need to go into this directory. Cut readme, and oh, build instructions, excellent. cmake -b build, I can execute that. And, all right. Then let's also do the other stuff, and we won't use anything actually being built, or won't use anything actually. I just wanted to show it nicely builds. Here all the things, interestingly, the networking proposal or the networking library depends on the execution library. That was all downloaded, so you don't need to go and bother getting that. It's just all there. All right, let's jump into VS Code. I've cheated a little bit. I've used that directory before, despite being freshly made. Here is the VS Code. And the screen sizes are all different. Excellent. All right, now I actually want to make it big because we will need a different window as well. Okay, so, all right. What I'm going to do is the thing does contain a bunch of examples. I will just use an example which I've set up to be empty. So empty isn't quite empty. It contains all the header files because it's not interesting to see people adding header files. It does contain a few namespace aliases and what I never can remember how to get the chronoliterals. It does contain some files I want to expose. So I try to make it so I know everybody over here is already ready to get hacking into my system. I try to prevent that a little bit by only serving these files. And otherwise, it's just a main. So there's nothing in here. It should build. This is what one would expect. And we will take it from there. So the plan. We basically, over here, we want to accept connections. So let's accept connections. Should be easy enough. So one thing to do that is kind of, the way I normally program is I basically start typing out what I want to do and then figure out what is missing. So if I want to do an async accept, it will tell me that effectively, well, I need an acceptor. Okay, fine. Or it doesn't tell me yet, but fine. I need an acceptor, and that will basically emit two things, pretty much as accept on AZ would do. This gives me basically a stream, which is for the client, and it also gives me an address. This is where the client came from. Now, that thing doesn't do anything. Async accept, well, first of all, I don't have an acceptor. Let's type these things in, but async accept also wants to be async. So just executing that will not get a connection. We will get to that in a moment, but let's quickly write out the other stuff. I need an acceptor. Okay, acceptor is, the namespace is a little bit annoying. So I actually need a little bit of a cheat sheet over here to do that. So it's basically an acceptor is an TCP acceptor and is an acceptor. Okay, fine. That gets two parameters. One parameter is a context and the other parameter is an endpoint. The context is basically the I/O connection, the I/O handling which is used. If you're used to pure POSIX, you know, actually I can accept without any context, I just need a file descriptor. However, that is actually not true on Windows when you use IOCP, IO completion ports, where you basically can only create a socket within one IOCP instance, then you cannot move it to a different socket. That's actually also true if you use something like IO-URing and you want to optimize things where you basically bind your file descriptor into one IO-URing context. So it's not just on Windows where we want that, we also want that on, well, for example, on Linux or anything else which uses something like IO-URing. All right, so IO context. And the other parameter this guy gets is an endpoint. So the endpoint is similar to the other one. This is basically just giving me the entity where, sorry, not an endpointer. This is basically the entity where do I listen on for the, in this case, for the acceptor. The endpoint can also be if you connect out, a client endpoint, but over here we This is just saying where listen to. So this is IP address. Before, I could use v6, but the typing becomes more annoying, so I don't do that. So the underlying system doesn't care whether it's before v6. And that should do that. Now, unfortunately, async accept is not declared, so we need to get that into namespace. That doesn't really do what we need or want to do because, well, it's async. So we could try to do something like async wait, although this won't work because we need to run something more. So sync wait is basically to say, all right, I have an asynchronous operation, and I want to actually not execute it asynchronously. I want to get the result back. What that does is it basically kicks off the process, sets up waiting, and waits until the process is done, and then comes back. That over here does not really work because we actually need to somehow run the context. So we need to do something different, which is fine because it actually does show what we normally will do, and that is we will just stick this thing into coroutine. And so the basic idea, deal with that. So the basic idea is async accept does return a sender. Senders are basically entities which can be kind of composed into other work possibly, and eventually basically kick it off. Over here, the kickoff will entirely be done by simply running things inside a coroutine and co-waiting things. So by the time when it hits the co-wait, it will just basically say, I want to get notified once the accept is ready, and then we will resume over here. While the accept is not ready, while nobody is connecting, this coroutine will then be entirely suspended. All right, so coroutine. Let's put in a coroutine. I will just, for simplicity, use a lambda into which I pass in the acceptor. Some people may wonder if I want to get an acceptor by reference into a coroutine, why do I not put that into the capture? That is basically something which is funny with coroutines. The coroutine function or declaration you write is actually kind of a coroutine, is a declaration of a factory for coroutines. And the capture goes away on the first suspend point. So you're actually not capturing whatever is in the capture for all the function. You only capture it until it suspends. And because we want to suspend and we want that acceptor to be alive, I rather pass it in as function parameters. Coroutines will keep all the function parameters and local variables and all of that alive, but they do not keep the lambda capture alive. All right, to make it a coroutine, I will do something which is basically saying, all right, I've implemented a task, which is not following the standard, it's just something because there's no proposal yet, but it's something which crucially is needed to actually use sender receivers effectively, I think, because I expect everybody to actually use sender receivers in a way you actually write a coroutine and you do inside the coroutine all your sender stuff. I will show, hopefully, an example later how to do it without being in a coroutine. Most of the time I will just use coroutines because it's a nice way to express the asynchronous logic. And for that we need task. Task is hopefully being proposed. It doesn't exist yet, but it's not hard to implement. If the standard does not define a task, you can basically implement it. You can download that version. It should be reasonably fine. And that's then our coroutine. Now, to get the acceptor in, I will need to basically invoke the function, and I dislike immediately invoked lambdas written by basically just invoking them at the end by using curlies. Oh man, I rather use that. The reason is it makes it way more visible that you actually actually executing it immediately rather than having a funny thing at the end of it. All right. So this basically gives us a task, a coroutine ready to run, all of that, but that still doesn't do anything because the coroutine is just sitting there. So we need to do something with the coroutine as well. And this is where the the scope thing I mentioned earlier comes in. So this is another thing which is not yet proposed, there were proposals, but they're not up to date. To get sender receiver actually working, we will also need a scope. Again, nothing super hard to implement, but it should be standardized. And hopefully we get that. So the idea of a scope is basically, this is a bucket for outstanding work. Whenever you have a sender and you want to basically have that executed, you just stick it into the scope, and this will start whatever work you have. And basically, once the work is done, it registers things to observe the sender's completion signals to basically say, all right, when I'm done, I just remove the thing. And eventually, if the scope doesn't hold anything, it can give you a signal, although the scope implementation not, I haven't come around doing that. It is intended to give you a signal, I'm done. Basically, it's giving you an on-empty sender, which you can register asynchronous work as well. So you could then basically wait on that. So we basically stick something into the scope. And this is basically just, I call it spawn, but there's no thread being spawned or something like that. And then to actually do work, because that still doesn't do any work, this is basically this coroutine thingy, and putting into a scope doesn't do any work. It basically just says, all right, I want to do this work. I basically need to have something like a context run, which is basically our run loop. Okay, so if I run that, I hope it compiles. It doesn't. It does not compile because of what? Well, yes, but but this should. Okay, interesting. Okay. Or maybe I put in a constraint here. Okay, cool. So that compiles, but if I run it, actually it won't do, well, we don't see anything. So is it actually running? No. Over here, come on. Oh, did I not set that up? Why does it not run anything? See, I did practice things, but then you deviate and then it doesn't work. So let's get rid of these. Maybe that is why it doesn't run. Okay, it's built. I will get it to run, but if necessary, not via this button. Okay, cool. Okay, this runs, but if I now actually connect something, let's say I go into a different window and just run curl against that, all we see is it terminates. This is not quite useful, so let's go and briefly receive client. And we can just go and say, all right, from address. This is not particularly interesting, but okay, and then also, because we probably don't want to terminate over here once we have received one client, let's put it directly into an infinite loop. And maybe we get around showing how to get out of that as well. Because one thing which senders and receivers is actually cool about is they have a cancellation built in. So by basically having a while loop and you having outstanding work in there, you can just cancel it and it gets out of that loop as well. Okay, so this should actually show us that we do a connection. We don't respond to it. We drop it directly on the floor, so the curl immediately terminates as well. But we basically have started the basics of a server. So this you can done reasonably synchronously, because at the moment we have only one work item anyway. So let's create the equivalent of, let's create something which actually does work. Let's say we do a make client handler, and we basically just move in the stream. It's a move only entity, of course. And let's just copy that, and I will just make the client handler a coroutine as well. In general, just because I make things coroutines over here does not mean that you have to make things as coroutines. And using coroutines is a little bit annoying because the coroutines actually do require allocations. None of the library uses any allocations whatsoever. And you can do all of these things without allocations as well, but then you cannot use coroutines. You have to write it in a slightly more contrived form, which may be a good performance optimization or be necessary to run in embedded devices where you cannot do allocations or something like that. It's all possible. It's just a little bit harder. But to just get used to using these things, let's just not bother with the complication. And then in here, we basically just go, right, this guy will be a coroutine as well. So we say it's a task. And to actually make it behave as a task, let's just for now put in a coroutine. And this would over here just create this client handler and drop it on the floor. This is again not what we want, so we basically need to stick that, like all the work we do wants to go pretty much into our scope, which also means we need to pass that in. So we get scope. And then we should have these things set up. Okay, something is not quite. Oh, I dropped an A by adding, yes. And it undersquiggly some other things, which are actually okay. Okay, cool. So inside the client handler, now all we need to do is basically pretty much as we would do in sequential code, we basically just keep reading until we have enough stuff, but we read asynchronously, so we actually never block. So to do that, let's say we get a buffer, and we can make it a little bit reasonably small so that we can see that it gets executed multiple times. And we basically aggregate, for simplicity, also using something allocation. I just built a request, and all I do over here is, I will actually do it a little bit contrived for something I hope to do later. I will do a while true, and then basically just do over here auto n. I basically just co-await reading from that socket. So co-await, this would be receive. That's basically an async receive, which takes a buffer and the stream. So async receive of stream and buffer. And this always returns an unsigned integer, where the integer 0 is returned when it couldn't read anything. This is exactly when we don't want to do anything anymore. Oh, I need to drop out of that. Okay, cool. What am I doing over here? So, because I didn't put it into the while loop, basically if n else, we basically break. Okay. This is just to avoid rewriting something a little bit later. So we read a buffer, and all we need to do is, well, maybe we start off with actually saying what we received. We received, let's say, data, because I need that a little bit more. Let's do a string view. Data, which is a buffer, and our n. And then we can actually already see if that compiles, we can see the, of course it doesn't. What does it run now? Oh, yes. You cannot just use a buffer directly, you need to put it into something like a net buffer. The reason for that is so that the function can, the async receive doesn't have to overload with an open-ended set of things where a buffer may come from. This is also just taken from ASIO, basically, to say, all right, we copy things into buffer. Okay, that should actually run, and we should see when we do our curl that we see, oh, stuff coming in. All right, cool. And we could at the same time, while this is live, create new connections because it's all asynchronous, it's just waiting over here. At the moment, the curl is waiting for a response. So we need to figure out when we have a response, and this will also be just fairly low-tech. We just go, okay, our request, we just add the data to it, and then we go if the request, if we can find in the request, okay, I need a string, basically an empty line, easy enough. Then we will just go and say, all right, we have found the end of the HTTP header. And that all we do now is I will put the implementation of what we do into another coroutine just to keep it a little bit cleaner. Now we get to ever more smaller work operations. Eventually I would put them probably into sender algorithms, but this is basically a manual translation of things, and we can figure out how to do that at some point. But so when we do process a request, we probably need the request. We will also need the stream to basically send the response to. So let's just do that. So we have basically another coroutine, process, reference to stream, and then our request. Well, make a const reference, which also becomes a task. And then, well, in here I will be rather blunt as well. I actually don't want to even be that. So the header we are interested in basically contains a method, the URL, and the version. So all I'm going to use is method, URL, and maybe version, and then just read these things. So if I actually get in string from our request, and I read that into message.
Question, the message header is spelled wrong.
See?
In the process argument, request is spelled wrong.
Okay, cool, thanks. We'll fix.
Just,
Yeah.
the compiler tells you.
Yes. So we have Jeff over here compiling things in there. Okay. So if we have that, let's just be really silly and avoid much error handling. If we don't set a body, we pretend we don't have that. If we do set the body, we have it. So basically, all I'm going to do is, if I have that, and let's put that as an end, and my files over here, if my files actually contain the URL, then I will actually also do, because I want to use that a little bit later as well, have an output stream, and I just slope in the data without much error checking, because in the real world we would actually error check, right? But so we take the files, URL, just open that, come on, and to slope it all in, take a buffer, and then we just set body is equals to out.str, and then reset out.str. Okay, so this is just normal programming. We basically just go slope in a buffer, and now we just need to produce a response, okay? The response will be straightforward. We basically just need to write a little bit of an HTTP header, and I will blatantly lie and claim that this is HTTP 1.1, although it does not really do that. I mean, so the next thing is the code. So the well-known, either if the body is empty, we basically say we haven't found anything. So body empty, then 4 not found. And otherwise we just say, and I misspelled not found, but okay, oh God. Don't make it better, I make it worse, right? So, okay, so this is basically just the header. To basically write the response, we'd also want to have a content length. Content length. Unfortunately, compiler won't check that yet. We need the metaprogramming stuff first. So we basically say, all right, it's the body size, and then a new line, and another new line. Okay, so that should be the response. We just get that out. Auto response is basically out.str. And then we go into, well, we could do a little bit blatant and say, all right, this is going to succeed. In the real world, we would probably error handle, but this is not the actually interesting bit. So let's do async send to our stream, and we need another buffer to send that response.
Do you want to append body? Yes, I was wondering about that.
Oh yeah, I probably want to append body, thanks. And we need a new line for the first line, that's also true. Thanks. Okay. So let's go first over here and verify that at the moment I don't load it, so the page which hopefully comes up is not there. So let's see whether it compiles actually first. No, it doesn't.
Should be two new lines between header and body.
Two new line between header and body, yes.
You spelled process wrong in the previous function. Yes,
Yes, I did. And there's contains. Oh, it's contains. Okay, cool. All right, excellent. So checking. Okay, I need to go elsewhere. Okay, running the guy, and now it should actually, if we go to curl over here, it actually does produce a response, right? So curl is happy. If curl is happy, let's see where our browser is happy as well. And, oh, I hate myself. So the browser is happy, but you see the broken link over there. It's kind of, oh man, really? Really? Where am I? I am in where?
Maybe try to run manually.
Oh, no. I know what it is. I need to do, actually not, I currently have a problem, right? I'm actually opening any URL. I want to do open files URL. Ah, come on. All right. Right, so this was just,
Maybe related to keep alive, like two requests are using the same string.
oh no, that's fine. The keep it alive, I'm pretty sure that I actually,
No, contains was correct.
yeah, contains is correct.
Was correct. You need to add a connection.
Oh,
Contains should ask for you check for URL.
okay, yes, no, you're right. Oh, and I actually do files URL over here.
Find the files.
It didn't find the file. And I did look for the right file because I'm running it in a terminal over here.
The logo has a slash in front.
Yeah, but if you look at what is actually requested, okay, let's do what we normally do in these cases. We actually put a little bit of debug output in, right? And get rid of the other debug output. Not this one, this one. Okay, that looked. Yeah, interesting. Why did it?
Because you hadn't
Oh, yes. Fair enough. Then it cannot work. Ah, come on. All right. Where is that code? Over here. So we probably go into here, I think. Well, we don't know, but this is the problem of making it a little bit too concise. What do we want to load? We want to load lots of slashes and a fav icon. That's weird. I don't know why that is, because this guy over here loading that. Oh, I need to run it. This works, and if I go and say logo.png, that. Oh, okay.
Wondering if it's related to content type.
Nah, it didn't care about that before. So basically, this guy actually said it did get it, right?
Probably trying to apply HTTP 1.0 instead of 1.1.
Nah, I don't think that's it. Anyway, we have seen that it actually loaded at least the page. It unfortunately didn't load the logo, which is embarrassing. And the colleague Dimitri, who basically proposed that I put the logo in there, is now disappointed. But I can tell Dimitri that I'm disappointed as well. But okay, let's rather look at something interesting, because so far we haven't actually done anything particularly interesting you wouldn't do in normal code. You basically set things up like that. Where senders and receivers, in my mind, start to shine. Shine is when you actually start composing work, and you basically do a little bit more with these things. And one of the things which I like is, let's say, my current server, somebody connects to it and doesn't say anything. We will stay on that forever, right? So if we do telnet and we just go localhost 12345, this will just stay forever. And so it's a very easy attack. Somebody comes and just creates enough connections, and it will just stay. So maybe we rather, instead of doing that, we rather time out our connection. And this is actually something which I think is pretty cool to show. And that is, the plan over here would be to go, all right, in our client, when we read over here, instead of just reading the buffer, let's put a timeout around that. And the timeout will need something like, let's say, 2 seconds, so we don't wait too long. It will take the sender for the async read. And, well, let's see whether we can go with that. And all there is basically the intention is basically to create something which sits there and either produces the result or the timeout. And if the timeout is, we basically want to fail. So timeout taking a duration and a sender, where the sender is the work we actually want to do. And it could actually, if you want to go there, we could make dots in here and do the same with many operations. For the current need, we don't need that. All I'm trying to say is that the timeout is actually or could be implemented reasonably general. So if we just return sender, we probably want to move that. If we just return sender, this is basically what we currently have. So, come on. But if we actually want to do other things, we could use an algorithm. This is, again, an algorithm which is not yet proposed in the standard library, but I hope it will eventually be proposed. This is basically when any. We could go and use the when any algorithm, which basically has the idea it takes multiple work items, and whenever any of these is finished, it terminates. Now, this would be just with one thing. This still doesn't change anything. So let's put a timeout in. So the timeout would basically be something like resume after, and we say we resume after duration. And if we actually get that, we want to turn that into something which is an error. There is an algorithm in the standard library called let, which allows you to build basically a sender where you return another sender. I've not implemented that, so I built instead a custom algorithm into error, which basically takes a function producing whatever error I want to produce. So let's give that a lambda, and the resume after actually doesn't produce any results, so all we need to do is to say we return an error. And the error I'm going to return will be just an error code. And into the error code, we can possibly stick in something like okay, let's put that maybe on a different line to keep it a little bit readable. Something like a demo timeout, which is something an error I define separately together with a demo a category. So we basically have a timeout error. But this is just whatever error this is. So this should actually turn the operation into something which errors after 2 seconds. And we can probably demo that, although what is currently going to happen is not pretty. If it compiles, oh God. Okay, you saw a glimpse of what might happen, and that is the error messages you sometimes get are huge. But the error should actually be fairly simple. Oh, yes. The error is very simple. It's actually missing parentheses. Oh, but not there, over there. The error is missing parentheses. I hope this is all there is to it. Too few template. Yes. Okay, there is an unfortunate caveat, and that is the resume after needs to know where to run. So I need to funnel that through. This is a little bit annoying, but it's basically saying, all right, we basically want to have a scheduler where we can run the resume after. And okay, I need to get that into here, fine. Then I get my timeout. Over here, I also need a scheduler. If I need a scheduler over here, I also need it over there. There is actually a technique to do that better, but setting that up is actually initially a little bit more work. So basically all the senders, when you execute them, they actually get a receiver from which you can get an environment. And it would be possible to channel something like a scheduler through the environment. It's basically the environment is a bag of properties which you need to forward. To actually do that through coroutines, because they're type erased, it's unfortunately a little bit fiddly. And again, something which I haven't quite done yet. So scheduler, so I basically just pass it through all the way, auto scheduler, and then I get a scheduler from my context, get scheduler. Okay, I hope I didn't have too many typos. I do have typos. Say?
Scheduler.
Oh, only 2 lines. Thanks. Scheduler. Okay, cool. So that compiles, then it should also run. And if I now do my telnet, it should be after 2 seconds. It comes, but unfortunately, it takes the server with it. The reason for that is, all right, this may be a little bit silly, but when you get do a core wait over here, like this core wait, it basically can easily return a value, and it needs to return or needs to process 2 other things. So basically, when there's a cancellation, it needs to cancel that, which basically means we drop the coroutine on the floor. And it needs to do something when an error happens. Now, if the sender we started with a core wait finishes with an error, the core wait will throw an exception. We can prove that easily out by basically wrapping that into a try-catch block. And we basically go and say, all right, yeah, let's try and catch that. And we do over here what I would catch. This is a little bit annoying, but this is actually an implementation detail of how things are put together in the coroutine task, which can entirely be fixed. I basically I get a variant of the possible error codes. And I have not tried it to make better. I have only one error. But in theory, a sender can have multiple different errors. And you can basically get all of them to get a variant of possibly all the errors. I think this guy should actually be a variant of error. So you basically should be able to see over here that this is then an error. SCD get of 0 of error. So it should throw that error. If I type thing, oh, so it's not this error, should be an error code. Now people would obviously argue, well, do we really, this is a little bit of a shortcoming if we need to do exceptions over here, right? And let's see whether that actually works. It does, okay, okay. And I don't terminate the subscription at the moment, and I should actually have set up over here to get a message out of that. And then basically we probably want to, after that, we want to break out of the loop. But not like that. Do I need an extra? Oh, I have an extra one. Okay, sorry. Okay, cool. So no, I need to actually run it. So this should actually produce the error and terminate the other guy. So error timeout. Also cool, but can we also do without an exception? And this is part of why I basically left the while loop a little bit funny, to say, actually, we could return something different. We could, in our timeout, rather than producing the result of when any and an error, we could actually use another tool we get. And we actually put that into another little algorithm into expected. To basically just say, all right, we turn the error code and the value into an expected with an error and a value. Now, this is not going to compile because it will tell me, hopefully, that the n over here is not an integer, because this n is not actually an integer but an expected, so we need to do value over here. And on the else branch, maybe do cout error, just to avoid confusing it with the other error, via expected, and this will again be this funny variant, so I need to get the value out of the variant, and this would be n dot error, I think, and then dot message. Okay. I hope that does a trick. This is not running. Okay, cool. Come on. All right, so if I do that, oh, I need to still run it. And then hopefully this now prints the error via expected and still the timeout. And I've avoided the exception. And this is pretty much a common theme to basically you get whatever results you get from upstream, and you may need to rewrite that into taking an error into a value and transforming it into something, which is pretty much what expected does. Right? It basically takes the error and turns the error into a value result, which is an expected indicating the error. And then we don't get the exception in the coroutine throw. Okay. So this is pretty much what I wanted to present. I hope that was useful for people. And if you have any questions, please ask questions. Thanks. Yes. Can you talk to the microphone?
I saw the coroutines are posted to like the scope, but there is no connect. Seems to me there's no connection with scope and context. How does context run invoke all these?
Okay.
Yeah.
So basically, whenever you do a co-wait, there's something being called on the entity within. Well, the entity, the argument is actually a sender. The sender needs to be turned by some library, actually by something like the tasks await transform into an awaitable. And an awaitable has basically three functions. One function saying, all right, are you ready? The task always says, no, I'm not ready, or this is not ready. And then it has an await suspend, which effectively calls under the hood some sender operations, in particular connect and start eventually, which basically are meant to say set up completion of this operation somehow. It knows where to send the completion of the operation because the stream where we ask things knows which context to run on. It basically goes to the stream, give me the context, and tells the context, when this kind of operation happens on this file descriptor, please wake me up. And this is basically what does the connection. This all looks nice and easy over here. I think the user experience is very easy. The underneath, the fiddling to actually make it work is quite fiddly. But this only needs to be done by few people who write the standard library. So in that sense, there's no magic involved. Anybody can actually do it, but it is not entirely trivial. You kind of need to put things apart. And then over here, when we do co-wait of something which is a little more complicated, then these things are nested. But each one's start algorithm or a start operation gets called, which basically does a relevant registration. I don't think this makes it particularly more clear. I think I would need a graph to basically show where that actually flows, which I don't have. And I'm happy to discuss that offline, but roughly this is what happens. Thanks. Anybody else? Yes?
Do you know if there's been any work to make coroutines use user-defined allocator or allow a buffer being given instead of having to allocate its own stack?
Okay, so that's not really related to senders, but it's fine. The way coroutines work is when you basically create a coroutine, you can pass in and actually something which has the allocator interface, I think. You say, is allocated, and you pass that in. I have an experimental version where I basically do that. And if you're interested, we can hack the task up to do that as well. So it would basically use the allocator to do whatever you do. And this would be the place where you could pass in a buffer. You would basically create an allocator which knows the buffer, or you create an allocator which does whatever it does. So you can get away with using coroutines without any heap allocations. You just set up a buffer, an allocator, and do that. If the standard task does not do that, let's assume that, anybody can write one which does it. So yeah, this will be entirely supported. In environments where you actually do not have allocations, I would expect that we actually, I don't know whether they would actually support coroutines at all. Like, I don't know whether on embedded systems you could actually use coroutines with allocator and all of that. Maybe you can, in which case you may be able to do it. Otherwise, you would basically rewrite these things into sender algorithms, composing things like, all right, here's an algorithm which does a loop, here's an algorithm which holds on to things. And there were plenty of other presentations which actually show some of these bits where senders are basically built out of other senders. So you don't need that, and you actually don't have any allocation. All right, thanks. Any other question? Yes? Yeah, ideally go to the mic then.
Is there a specific reason you use variant on the try-catch statement instead of polymorphic exceptions? Not polymorphic. What's the? So like, yeah.
An exception base.
Yeah.
Well, okay. So the entire handling of what error type do you get is basically put into the logic. I think in this case, it's a coroutine in the end, which basically gets it. So no, other way around. So each sender declares what kind of completions it has. Inside these completions are errors. And the expectation is, in my mind, that we will not allocate things. So we actually want to return a value. And I don't want to have a hierarchy over here, really. So to actually return a value, if you have multiple options, the easiest way is actually to stick that into a variant.
Oh, I see.
What I should have done, but I haven't got around doing it, and when I tried to do that yesterday quickly, I failed, is to say, if there's actually only one error, like the sender, which is called, reports only one error. I don't need to stick that into a variant. I just destructure it and basically, or avoid putting it into variant and return an error code. In which case, I could have just called an error code.
All right. So just to confirm that we're on the same page. The reason you don't have like multiple catch statements is because you don't want allocations because of exceptions?
Well, okay, multiple catch statement is also a problem. Well, no, it's not. Actually, you could destructure the thing in the task as well. Yeah. Okay, I've not done that. I didn't quite get that idea, but yeah, you could do that as well. To go, right, I get a variant, fine. I basically call visit and throw whatever I get.
Right.
Would be very easy to do, actually. Yeah. Yes.
So there's no specific reason you
No.
go for. Okay,
No.
Thank you so much.
Just not thinking about that.
All right. Good talk. Thank you so much.
Okay, cool, thanks. Anything else?
So this Beeman project thing seems really cool.
I didn't plant him, but okay.
Yeah, I might be a plant since we have the same shirt on somehow. Do you have some stickers there?
I do have some stickers. Yeah. So if people are interested in the Beeman project, there's a bunch of stickers, and Jeff is happy to distribute them.
I will pass these out and go to David's talk on Wednesday. Yeah, there'll be T-shirts, really nice T-shirts.
Okay, cool. Yeah, just.
Okay, I have a question.
Well, there are two other questions first.
Is it possible to unit test this code?
Is it possible to unit test that code? Yes, it is. The networking stuff I've implemented currently has only one backend, which is using Paul. But I just need to port prior implementations to it to have something like a test backend, so you can actually simulate I/O operations, for example. For testing senders or sender algorithms, you probably use sync weight. You do everything synchronous, most likely, but you can also test the asynchronousy a bit. And the networking implementation I have right here does not have a lot of tests, but there will be tests coming, hopefully in short notice. I basically have imported them from the implementation I had before when porting it to the Beeman implementation. So, and then, oh, you had your hand up, yes? Oh, okay. Okay, cool. Yeah.
It's not set up. So, a question about Beeman projects. Like you have this demo task, and probably there is also a lot of coroutine related stuff like generator I can name, which would be nice to have. Are you going to implement it in Beeman projects?
So the answer to that is, well, the Beeman project is entirely a volunteer project, right? We basically can look at, okay, let's start off that. There's a link. You can entirely go there and see what is already covered. It's actually currently not many things. We are relatively early days. But part of the reason why I actually rushed to put everything into Beeman is to advertise it over here so that maybe people help me in the projects I do, which is std execution and basically tracking the net proposal. But I think is there a generator proposal? I don't know, offhand. But whatever has a standards paper and has a proposal is actually eligible to become a Beeman project if there's a volunteer who does it.
That's right, and there's lots of different ways you can participate. You can just participate by doing reviews, which gets more eyes on standard proposals earlier. You can try to implement one of these from some of the wording and some of the paper. That's very beneficial to us to have that activity going on. I don't know, is Steve Downey here in the conference or is he?
I think he is at the conference.
So
but I don't know.
you'll see the optional 26. This is actually 2 proposals for C++ 26, optional reference, and what was the other half of it? Anyway, there's 2 papers represented there, and I can tell you, having participated in the reviews and the discussions, and others who are here can tell you that it was a very spirited and useful discussion for Steve in refining that proposal before it came to the committee, which is the entire point of this project, is to get all of the answers ahead of time so that when the committee is looking at something, that it's really solid.
Yeah.
So.
And to be fair, it's not just that, it's also things like just trying things out. I unfortunately also didn't manage to produce for the networking stuff and something like a compiler explorer link, but for the execution stuff I had, if I can bring that up. There's, for example, a link to actually, for stop token stuff, to actually try things out in compiler explorer if you want to. Or you basically download the library and you run it the way I did, which is relatively straightforward. It's also useful to actually get feedback from people trying to use things. But to be honest, I don't want to take all the power out of David's Wednesday talk, who is hopefully talking way more about any of these details.
There'll be t-shirts there. So.
There will be t-shirts there, yeah. So if you want to get one of these cool t-shirts, there's only a small supply, but you will need to go to David's talk. Okay, cool. Then I think we are at or over time. Thank you very much